I am Pragyanshu, currently working at Threatsys as security engineer. I welcome you all here. So I'm really glad you all are here. Whether you are a red teamer, blue teamer, or someone just wondering why AI pipelines suddenly started mining crypto, you are in right place. So let's start with our today's agenda, Langflow. Let's have a quick introduction about Langflow first. Langflow is a system that automates AI workflows using large language models. Imagine building an agent, AI agent, automation pipelines, or chatbots, not with dozens of codes, but with drag and drop building blocks. Now that's a dream for data scientists and engineers. But that dream is also for attackers, especially when such tools are exposed to the internet with very little security wrapped around them. Langflow is used in early stage startups, internal R&D projects, hackathons, and also in major companies. But in the rush to innovate, some corners like input validation or authentication tend to get overlooked. So today I invite you all where I will be unpacking a critical vulnerability that turns productivity booster into attack vector. Examine how it is being exploited in the wild and introduce you to not so friendly guest called Flodrix Botnet. Stay with me because that follows is what follows is equal parts alarming and eye-opening. Let's dig into risks, realities, and most importantly, what we can do about it. We are at Threatsys Technologies Private Limited. We are a Certins Associated and ISO 27001 certified cybersecurity company. That's been in the game for around 12 years. We have worked across industries such as finance, healthcare, oil and gas, manufacturing, and are in delivering end-to-end protection for both domestic and global clients. So that's what our company. So here's what we have got lined up for today. We'll start by getting familiar with Langflow, what it is, how it works, and what it is become such a hot target. Next, we'll move into a live demonstration where I'll show you how our CVE-2025-3248 can be exploited, walking through mechanisms of the vulnerability. Once we understand that threat landscape, we will cover how to detect such activities, mitigate exposure, or harden your AIML orchestration environments. And finally, we'll wrap up with practical incident response checklist, something that you can use right away in your organization to assess readiness. So let's get started with understanding Langflow, how it stands as a developer. Tool can be turned into liabilities when security is an afterthought. So as the slide suggests, why does this even matter? So Langflow is more than just a dev tool. It is a visual interface to build complex LLM workflows with so much of little friction. Think of it as a control panel for AI agents, pipelines, or orchestrations. It integrates directly with LangChain, and developers use it to hook into tools like OpenAI, Hugging Face, Pinecone, or even vector databases such as VB8 or Chroma. It's being actively used in open source AI projects, internal tooling in startups, and even in enterprise POCs for building intelligent customer support bots. Now here's the problem. Langflow runs on a REST API backend that processes user-submitted Python code. And in versions prior to 1.3.0, that code was executed without any authentication or sandboxing. I repeat again, without any authentication and sandboxing. This only leads us to our vulnerability, a critical remote code execution that gives attacker unauthenticated access to execute arbitrary code on the server, essentially handing them like a key to the AI control room. In the real world, this means if an attacker finds an exposed Langflow instance, they can weaponize it in seconds, deploy malware, install crypto miners, or even hijack the AI agents to leak data and execute commands internally. We have seen the evidence of this being exploited in the wild, especially in the test environments that were promoted to production without any hardening. And once the Flodrix get in, the real fun begins, but we'll get there in a moment. So let's take a closer look at how Langflow actually functions under the hood and why its architecture introduces us both power and risk. Langflow provides a visual interface for designing LLM workflows using pre-built custom nodes. It's tightly integrated with LangChain, and behind the scene, it converts these visual blocks into serialized Python code that gets executed dynamically. In terms of deployment modes, you will commonly see Langflow spun as a Docker container or deployed via Fast API on a cloud VM. Unfortunately, many developers run it on exposed ports without any authentication while testing. And we all know how often testing environments quietly go into production. Now the core use cases are exciting. Langflow powers smart chatbot, internal knowledge agents, AI-driven task runners, and even automated data processors. That's you will find it linked with tools like Pinecone, Langsmith, and all. But here's the critical part. Langflow's backend exposes a set of RESTful APIs, including the endpoint validate code and API run, which accepts Python raw code from the front end and execute it to validate user workflows. Sound flexible, right? But it may be too flexible. This is where the CVE comes in. When attacker discovers that the API could execute unauthenticated, unfiltered Python, they saw a playground. What we should have been helper function for validating workflows became open shell for the host system. So therefore, it is very dangerous. Here's why the things are really interesting and dangerous. At the core of this CVE-3248 is an insecure deserialization flaw. Specifically, it targets post API run endpoint in the Langflow's backend. The vulnerability stems from a misuse of serialization library called JSON-Pickle. JSON-Pickle is a tool meant to convert complex Python objects into JSON and back. On the surface, it seems harmless, but under the hood, it uses Python's native pickle module, which, unlike JSON, is not safe to use with untrusted inputs. So what happens here is an attacker sends a payload that looks like a benign JSON object, but what actually gets passed to the backend is a pickled object crafted to execute arbitrary code during deserialization. This is achieved using reduce method, a special function in Python that controls how objects are serialized and deserialized. By, by overriding it, an attacker can inject system-level commands like creating a reverse shell or dropping a malicious binary. This is a textbook case of remote code execution via insecure deserialization. It's made worse by the fact that there is no authentication or sandboxing on the endpoint. Now let's look at the other door attackers are using through an unsanitized call in Python's exec function. This particular issue affects Langflow version prior to 1.2.0. The vulnerable endpoint is validate code. What happens here is that the backend blindly accepts the user submitted Python code from the frontend and runs it using exec function without any sandboxing, filtering, or authentication. Let me say that again. It executes raw Python code from user as is. That's giving like a stranger root access and hoping they were just there to see the UI. The code is evaluated in full trust, which means attacker can trigger anything from OS level command injections to reverse shells. When when Langflow passes this function during validation, that is import OS dot system who am I, it gets executed instantly without even checking what it actually is. Just default arguments is enough to trigger execution. That's the kicker, it bypasses naive safeguards like checking whether the code block calls eval or os.system function directly. It exploits via side channel behavior in Python syntax. Between this exec function and deserialization bug we just saw in the earlier slide, Langflow essentially hands attackers two different remote shells to choose from. And unfortunately, many did. Now what we will do is perform a live demo execution where I will be deploying a Langflow container in a Docker. That is, I have already deployed, and then we will be taking trying to do a C from there. First, what we will be doing here is starting our Docker and Langflow init. So sudo let me start our Langflow. It is something. Hmm. So what we are doing here is, oh, so Docker isn't started yet. Let me run it again. Change करने my Docker here, in which Langflow is there, and I have checked. As you can see, my Docker is running the Langflow. Okay, so what will we first be doing will be a sanity check. But we'll check that our request is going to the API or not. For that, we'll do a curl command, and as just shown, this means that we are getting a response from the API, that is validate code. So now we'll be entering our payload. So as you can see, I have my payload here right now. That is, I have named it on the CVE itself. So you can also have a look inside the CVE. So this is my payload, and I will be running this on that validate code API endpoint. So Let's first start a listener port where we will be getting the reverse shell access. So let's start a listener via netcat on port 444. So our listener is running. So now we'll be sending our payload. So this is my payload, and we are running it on the API endpoint that is validate code. So let's see. Yeah, see, we have got the reverse shell access here. As you can see, we did run the listener here. So we ran our payload there. It was executed, and we got a reverse shell access here. So let's confirm it. Who am I? It says user. Okay. So now what we will be doing is we will be running a few sets of command to show you the full extent of what we can do by getting this reverse shell access. Let's first check the details about the system that is running. And that is uname -a. You can clearly see the details of the system here, Linux, that is device ID and all, what's the version running and all on that. Next, let's see the read access, verify the read access about this. Let's say, see, there are already two things in this folder right now. Let's try to create a new folder or new files here to confirm the write access also. For that, what are we doing using a touch for this? Touch /temp / let's say here by me. Let's verify that it was executed or not. Let's -la to view this. As you can see that a new file was created that is here by me. So it confirms that we have got root, we have got the write access here, also the read access. So we can fully compromise the system right now. Now what comes is a thing called persistent simulation. Let's say a developer was running his vulnerable Langflow instance somewhere, but he takes break and shut down his PC or laptop. So while the system is down, we won't be able to get any shell access. Okay, so we can do this as we can do a thing that will give us a shell automatically whenever the system turns on. That is, we can get a persistent simulation here. By running this command, what we are doing is that whenever the developer system runs, we will get a shell automatically to our system. Okay, just we have to do is start our listener and we will be again in the system. Now what we can do is let's see, we can get an environmental details about this system. Yes, we can. We got the host name, Python version and all, open API key. It is a test environment, so it is set to dummy, but in real environment, it should be something. That is GPG key. So we got very much detailed things about this. Let's see what can we get the password file. That is about details about the users and hosts. Yes, we can. So it's a classic case of remote code execution. We had got everything that we can get in a remote code. After this is something that what we have done till now is simulated that we got a remote code execution at vulnerable Langflow endpoint. And it is associated also with Flodrix botnet. For this, we can so about Flodrix. Now that we have walked through how access is gained, let's look at what attackers do after they get access specifically. How to automate using Flodrix botnet. Before we go into Flodrix and in detail, first thing that I want to say that I won't be demonstrating any Flodrix deployment itself, because this is about education and telling all things, but not enabling malicious behavior. Instead, I'll show you a safe simulation of how a compromised system might have once Flodrix established a foothold. What we will be doing is uh, running a new listener at a different port. Let's say uh, I'm running a listener here, new listener, trace. So our listener is running. We here start by creating a mock command control server, C2 server using Netcat, which is listening on port 9999. This simulates what an attacker would use to receive signal from infected devices. Now what we will be doing is we'll be running a command that will beacon its host name after every 10 seconds automatically. So let's kill this shell for now. What this sort of payload does is we are sending a curl request that will beacon its host name and date timestamp, and it will tell the system to sleep for 10 seconds, and it will do again and again because we are binding it in a while loop. So let's run it. Yeah, curl failed. Okay, my IP might have been changed. Let me check. IF fake 26130. See. 26.130. So it should work right now. Yeah. This was the listener port we activated, and we have got the system detail, that is host name and today's date and timestamp. Okay. So this shows that what we have done here exactly is we simulated infected host beaconing back to us. What it does is sends basic telemetry like host name and timestamp, something Flodrix would do to maintain situational awareness and confirm the host is still under control. In real scenario, this beacon could also deliver payload, execution logs, receive new commands, or even fetch binary updates. So what Flodrix exactly is, Flodrix botnet is a lightweight encrypted and designed to operate quietly. Once embedded, it can execute DDoS attacks, move laterally, or drop secondary payloads, all without raising any alarm if proper logging is in place. So that was all about the live execution. So let's get back with our we have gone through all these commands right now in the live execution. We have established a proof of full control. We have created a new file there. We also discussed about persistent simulation. We also did environment exploitation. We also shown you that how a Flodrix botnet will work after exploitation. So we have done live execution. We have done introduction about line flow. Now let's talk defense, because detecting these kind of exploitation can only make the difference an isolated compromise and a full infrastructure fallout. We'll break detection down into few things. Let's first see how we can detect on a network level. What we have to do here is keep an eye on API traffic, specifically to post requests such as API run and validate code. These are entry points attacker use in normal usage. They shouldn't be receiving any complex payloads at scale. You should also monitor outbound traffic to know where to known or newly registered IPs, especially unusual ports. We can also use IDS tools such as Suricata, Snort, or even Yara rules can be configured to look for specific traits such as pickle encoded objects, base 64 blobs in post bodies, abnormal API usage frequency, repeated HTTP beaconing at fixed intervals. And on host level, we can look for or monitor some suspicious process and activities in Langflow container itself, such as commands such as curl, bash, sh are being executed within the container or not. We can also watch the file system, especially temp, var temp. These are the common drop points for botnet payloads. And at the endpoint level, detection gets even more granular. What we can look for is a process trees that such as Langflow to Python to curl or Langflow to Python to sh. These relationships are rare under normal operations and are behavioral detection engines. We can also look for unusual shell spawn inside the container, unexpected parent-child combinations, memory scraping, and accidental API exposure in logs. So we got to know about what are the detection strategies we can employ. Now let's get on with mitigation. Now shift our detection from prevention. These are the steps mentioned here in the slide, can be used by any running Langflow or LLM platforms. First and foremost is that we should update our Langflow version to 1.3.0 or higher. This version addresses both the issues that was exec function and insecure initialization. What it does this by introducing a safer address handling and removing JSON pickle. Another thing what we can do here is use Pydantic or JSON schema to validate inputs. We can and we should also enable authentication on all API endpoints, specifically on those two vulnerable endpoints such as API run and validate code. We can also disallow use of unsafe formats like pickle or suspicious 64 base 64 blobs. This type of input should raise flag and not pass quietly. We can also make Docker containers read-only, specifically in folders such as temp and var temp. As we had seen in the execution, we got write access in the temp folder only. Another thing what we can do is always run our services in non-root user access level, because it will reduce the blast radius if the system will actually be compromised. Another thing is that we can also deploy a firewall in front of Langflow, and we can also limit the egress from our container to the trusted domains and known IPs. So basically, for prevention is like hardening doesn't mean locking everything down. It means applying friction where attackers expect smooth sailing. So now, as we all know, no matter how strong our defenses are, sometimes breach occurs. So here's a simple but effective incident response checklist that we all can use. What sort of immediate actions can we take? So in that case, we first what should we do is stop the spread. What we could do is detach it from the network immediately. Our container where the Langflow is hosted, we can detach it immediately. If it's in a container, we could pause it or shut it down, and we shouldn't let it beacon or pull more payloads from the attacker's machine. We can terminate. We should terminate any active shells that are running, and before cleaning the container or house, we should take a snapshot of everything so that we can use it for forensic image or a post-mortem analysis if something legally can be done about that or not. On a system level, if there is a sign of persistence, like .bash RC mods, temp files, or backdoor binaries, we should wipe it and redeploy our all images that we are used in the container. We should also reset any API keys, SSH credentials, or tokens or service that we had access to. Assume everything stored in the memory or config was compromised. The next step is threat hunting, in which what we were doing is checking the internal logs for strange logins, sudo attempts, and unexpected access to other services. We can use these IOCs for compromised host to scan our entire network. And after that comes post-incident security, in which we should lock down our Langflow endpoint, restrict to internal access or VPN only if possible. Consider setting up, what we can do, another thing is that we can set up a honeypot Langflow against our original Langflow. If someone hits the honeypot one, we can get the early warning that someone will be trying to access it or not. Finally, we can conduct a post-mortem, what worked, what didn't, turn this incident into a blueprint for a better preparedness. All right, we have reached our final stretch today. It's QA time. This is where you get to flip the script, ask the slide. As the slide suggests, hit me with your best shot. I am all ears, and absolutely no more lifestyles, just questions. So you can write your questions in a comment section, and I'll be addressing that. I'm waiting for the questions. If any of you guys had any query with our session right now, and any query about how we did it, how the attack was simulated, any benign query will also be entertained. We can ask and we will clarify it. So about the reverse shell, what we did was we started our listener. So I saw the questions in the comment section. So according to that, I can find only one question that is suitable for answering. That is, Mama has asked, how did we get a reverse shell? So what we did was start our listener at port, any design port you can choose. We used Netcat to start a listener there, and what we did was executed our payload at the validate code endpoint, and by which we got the access to the listening port, and the reverse shell was started. So Himanshu have asked that how did attackers weaponize this vulnerability to distribute the Flodrix botnet, and what operational risk does this create? So attackers weaponize this by exploiting weak or difficult, that is default credentials on exposed Microsoft SQL servers. Once in, they deployed the malware using SQL commands and PowerShell scripts, turning servers into a part of a botnet. This creates a serious operational risk, including system compromise. You can list it as data exfiltration, service disruption, maybe reputational damage. Okay. So I think that was all the questions were answered, and that brings us to the end of this today's session. Thank you all for being such an engaged and thoughtful audience. What we did today was explored how we misused exec function and insecure declaration that turned AI orchestration platform into attack surface, how that opened the door to full compromise and post exploitation with Pragyanshu botnet. More importantly, we looked how to detect, mitigate, and respond, because tools like Langflow are powerful, but that power must be matched with discipline and secure design. I hope this session gave you practical takeaways, whether you are defending your infrastructure or helping others secure theirs. Feel free to connect with me after the session or reach out to the Threatsys team if you'd like more details, guidance, or a deeper discussion. Once again, thank you and stay secure. And we also have a next session scheduled about nuclei from 3 p.m. So stay tuned. Signing out.
Each and everyone present here, it's a pleasure to welcome you all to today's webinar on Nuclei, that a practical guide. I am Ayusha Sahoo, a security engineer at Threatsys Technology Private Limited. We are truly glad to have such a diverse audience today, including cybersecurity professionals, students, developers, and tech explorers who are eagerly to explore efficient way to perform vulnerability scanning. So before going to our technical topic on Nuclei, that how it enhances your vulnerability by using the customized template and worldwide target like API, web, cloud, and DSL. So let me give you a brief overview of my company that I represent. Threatsys is a certain associated and ISO certified cybersecurity company with over 12 years of experience securing digital across industry like banking, healthcare, oil and gas, and more, both in India and globally. So we specialized in end-to-end security consulting like compliance audit and advanced managed SOC solutions. Our team that of certified experts use the latest threat intelligence and automation and industry for best practices to deliver proactive, reliable, and scalable security outcomes. So, in this today's session, we'll introduce the Nuclei, which is a fast and flexible vulnerability scanning tool that align with your practically. So, let's take a quick look at what we have learned in today's session. First, we have explored the nuclei, like how the nucleus works and why it is considered a game changer in the world of the vulnerability scanning. Next, we will go to the structure of nuclei like YML templates, learning how to easy it is to create, customize, and run scan using these human related templates. Then we will see how to integrate nuclei with buffshoot, combining nuclei automated scanning power with buff manually testing strength. And finally, we will walk through the live demo of Nuclei in the real world scenario. So let's walk through the agenda for today's session. We are going to start with a brief overview of what Nuclei is and why it becomes such a vulnerable tool in cybersecurity community. Then we will expose the key features that are associated with the type of vulnerabilities like uh, include those from the OWASP top 10 and beyond. So next we'll walk through the installation and setup process and so how to run scan efficiently. We also cover how to write custom templates for use cases and see how to integrate Nuclei with Bobshoot to enhance your testing workflow. Then we have take a real time demonstration that will follow to show you everything in the action. Finally, we will wrap up with some best practices and common challenges and then open to the floor for your question and answer session. So let's go to our next slide. Okay, so it is based on the overview of Nuclei. So Nuclei is a fast and open source vulnerability scanner that designed for the automatic testing across API, infrastructure, cloud, and DNS. So what makes Nuclei unique? It is use of YML-based templates. These templates allow you to scan for known vulnerabilities like misconfiguration and weak security pattern in a highly customizable way. It is a widely trusted and used by the security engines like bug bounty hunters, security users around the world for its speed. And shortly, Nuclei make it easier to integrate your security. So come to our next slide, which is based on the key features. We have found many more features in the we have found many more features, but we have taken some kind of six features which are mainly associated with the nucleus. The first one is lightweight and high speed scanning engine. On the technical side, it is a lightweight and high speed scanning engine which is fast performance even during large scale scans also. So the second one is YML based reusable templates which make it extremely easy to write, share and manage security checks in the structured format. Then in the third, it can support multiple protocols like HTTP, DNS, TCP, and SSL, target a wide of service. So then we have the large and active community template repository, which means you can use thousands of pre-built templates at a single time. Then we have the parallel scanning with optimized performance. It means you can use multiple templates and multiple URL at a simultaneously. Then at the end we have an flexible output. Here Nuclei offers a output format like HTML and Markdown, making it easy to integrate result into dashboard or report or further any analyze of your workflow. So go through our next slide, which is mainly focused vulnerabilities. So we have taken like five type of vulnerabilities which are mainly focused. So in the first one is API misconfiguration. So let's say took a overview for the first vulnerability, which is API misconfiguration, that can detect some common API weaknesses like missing authentication on sensitive data, or having any vulnerability like broken access control, for example, on the endpoints like admin or regular user or non-admin users. So in the third, it has sensitive data exposed, such as user personal information leaking through API or users. Then in the second vulnerability, we found that infrastructure weakness. So in here, we can identify some misconfigured HTTP header like missing SPREM option, which is lead to click jacking, or some exposed admin panel like PHP, MyAdmin, or admin, some kind of admin panel that are accessible. And in the third, having the outdated web server version that are associated to know with the CVE. Then we have then we have the third vulnerability like cloud expose and misconfiguration. So in the cloud expose and misconfiguration, the flag cloud issues such as hardcode AWS keys found in JavaScript file, or any public cloud storage leaking any sensitive file, or any internal backups. So in the fourth, we have CVE and non-exploit. It's a capable of detecting like a high impact vulnerability. Uh, some of example like RC, SQL injection, command injection, among other, using regularly update templates from the community and threat intelligence. And the last, we have the custom checks for unique environment, that can also write your own template for your test, like use some kind of important features, which is hidden debug endpoints, unsafe file uploads, or any business logic flow, any parameter manipulation that could be bypass your validation or any access. So these are the mainly focused vulnerability we have talked. So go through our next slide, which is based on the templates and structure. So let's talk about one of the coolest thing that makes Nuclei so powerful, that it's modular YML templates. At the core of the every template, we start with the information block, like you have the identify card of the template, include like the ID or the name or the author who created the template, and a quick description, basically what is the template detect and how it can detect. So in the request body, so in the Nuclei also support like a reference, so you can attach things like CV ID, CW number, and even external documentation links also. So next we have got the request session. This is where the actual magic happens, like where we define how the template will interact with the targets. Like whenever you found a targeted URL, you can just attach this request with this template. First we have to the HTTP method like get, post, put, delete, whatever fits in the templates. So then we have the headers, cookies, and query parameters, even the request body if needed. And the HTTP that you can write templates for DNS, TCP, or even file-based checks also. So then comes the matchers. Basically, Basically, this is how Nuclei decide whether something is vulnerable or not. Like you can match based on status code, like 200 OK or 4000 400. like any error is happening. So specific word or patterns you can see in the response, or any headers, binary signature, and many more things you can add inside the matchers. So you will even combine matchers using AND or logic to make your detection more precise. Okay, so let's talk about tags which are used inside the templates. Like tags are simply keywords used to organize templates. For example, you might tag something as CV, DNS, API, WordPress, Apache, or Cloud. This makes searching and grouping templates really easy, especially when you are using automation or template filters. So, in the final, we have the best part, that is users can build private and customized template. Like you can create a private template to your own application logic. So if you have any unique endpoint or custom business logic, then you can build your own internal scanners using the same YML format. No need of any online search. So in short, Nuclei templates are modular, flexible, and extremely readable. And the main part is you can customize by yourself. So these are the steps we have in this slide, which is briefly described uh, our session what are inside on a template. So go to our next slide, which is based on writing custom templates. So let's quick walk through the basic structure. So here we have written something like ID, information block, wrapped request, matches, payload, testing, or your path for your custom template that you made. So first one is ID. ID is this is a unique identifier for your template, like a name tag that can help Nuclei recognize it. Then we have the information block, where you can put the things like name, author, severity, or any tags, or think of it as about me section of your template. Like you can also add the description inside inside the information block. Then we have the crafted request. This is where you actually craft your scan logic. Like you define the request method, the path, header, and everything you need to interact with the target. Then we have the request block, where you also define matchers. Like these are the condition I already I already told you as the previous slide. Like these are the conditions used to decide whether a response is indicated a vulnerability or not. For example, you might be matching for a specific status code or string in the response body. Then we have the testing, which is validity is marked as true. Like if you are testing with different inputs, you will use the payload section. Like you can supply a list of payload or word list that get injected into the request to simulate attackers or variation. So then we have the custom template path. Like when you are doing writing, save the file with a .yml extension. For example, path to custom template.yml extension. So after running your scan, the Nuclei makes successfully hit with a flag called validate true. So go through our also I have a sorry. Also I have giving a picture on this slide which is briefly describe about that example we have taken for a template. So the next one is example for template and structure. In the previous slide, what kind of say section I was told. In this slide, you have to see a example that I've taken on the vulnerability name reflected excesses. So in this slide, we have the identifier name reflected. So starting the top, we have the ID, which is just the unique name for the template in case it called reflected excesses. So under the information block, I have told we have the information like name, author, severity, and the metadata. The name is like we have put here reflected excesses in the author section. We can have the list of author, those who are generated, and the severity, we have the severity. Then the metadata mention it use a max of one request for target. And finally the tags, which is XSS or any dash, help classify to filtering your automation scan. Then we defined a variable called fast, which is a generated random number between 10,000 to 99,999. This has create dynamic payload, so we can uniquely track if our input come back in this response. Then we will move to the heart of our template, which is HTTP section. So in this section we defined a precondition that says only run this template if the request method is get. Like we have put it this data inside a template. Under the payload, you can define a group called reflection. Like it includes three classic reflected XSS payload you have noticed. So how each includes our dynamic first, which we are used for the variable inside sum of character. These are crafted to test if the application reflected them unsanitized. Then now here we come to the fun part, that is fusing. So inside this part we have like two request bodies. First one the query string and the second one is the path. In the path, like we have the search or input section, or in the query string we have the parameter in the URLs. So we have taken these two parts for this request body. For both, we are appending our XSS payload to see if the server reflected them back. So then we use stop at fast match, which is marked as true. It means Nuclei to stop scanning once it find a positive result. Then that saves time and avoids flooding the server. Okay, then go to our next slide, which which is based on some basic commands I have, like when someone is using a Nuclei. So these are the basic command you have to use. So first I have written that Nuclei dash u with the targeted URL. So this can indicates like scan a single URL using the default setup template and do it quick and easily. So next command 2 we have nuclei dash l url dot txt. If you have multiple URLs, then maybe from the crawler, just put them into a file and Nuclei will process them all one by one. Then command 3 we have nuclei dash t, where we can put our templates. Then we have the categorize command 4, which is nuclei dash t cvs. Like this run all the templates in the CV folder which you have saved earlier. You can also use other folder like misconfiguration, expose, and many more. So in the command 5, that nuclear dash 0 result.txt, by using the dash 0 we can save our text file. Then in the command 6, that nuclear dash tag xss.dast. So in here you can run only relevant templates that you want to scan. Here we are targeting all templates tag as like XSS or dash related. So in the next command we have nuclei dash rate limiting 50. Yes. So this is very useful for live or any production system. Like this limit the number of requests per second to avoid overloading the target. Okay, then we have command 8, that is nuclei dash t, where we can put our templates path to scan our targeted URL. Then we have the command 9, that is nuclei dash update dash templates, like whenever you install a URL from the online, then then it can give like 7,000 plus templates in your system. After that you should update your all of the templates you have used. And finally, command 6 is that dash list barf underscore scope dot txt. So this is for integration with Bufshoot. Export the scope or proxy history from BOR, and Nuclei can scan those target directly. So with these 10 command, you can see the other slide that related with this command. So let's go to our next slide. So it is based on the demonstration that I told. Like first, in the first step, we have to install and configure Nuclei. Then we have to fix a target for scanning. Then we select a specific template for a specific vulnerability. Then when we got all the data or information, then we save a report or save that file in a text file. Then we have the best practice for using Nuclei responsibly. So let's start all these steps manually. In the first step, we have installed and configured Nuclei. So in here, we can we can use a URL from the online, that is project discovery from the GitHub with the version 3, which is latest. After installation of all the Nuclei, you can verify your installation by putting the dash version, that you can show like which version you installed. For after the installation, you have got 70,000 plus template. So you have to update all the templates by putting this command, that is dash update and dash templates. So in this slide, we can run a basic scan on a target, that as I told you, we have to put a targeted URL like nuclei-u with the vulnerable targeted URL. Here we have taken a test php.web.com. It is a vulnerable site. It is also using for the testing purpose only. So we have taken here. Inside that, like when we click on enter, you can see that it can find some informative bug with HTTP missing security headers, content security policy, or HTTP missing security headers, extreme option, or inside in the below session you can see the version that can display here. It is also a low bug. So we can found all these things by putting that targeted URL inside the scan. So in this slide we have selected specific templates, like we have put a command nuclei-u for the URL and dash dst-t where we can put our specific template to get the result with the vulnerability name with the severity. So inside that you can see as it mark as a red block, that is reflected excesses with the severity medium. So after putting all the command, you can get the output like this. So we have taken another example like dash t with the templates, that is SQL error based. Yes, you have a question that where we can found these templates. So when you start install the Nuclei, you can got all the Nuclei template inside your user, as it save as your name, and inside that it have a folder Nuclei templates. At the inside of the Nuclei templates, you have got all the list of the vulnerabilities that you want to find. Okay, then whenever we put the path of the SQL error based YML templates, it can give the result, that is SQL error based with the severity critical, and also giving a description, that is check the manually. that corresponding to your MySQL server. Okay, as putting this command on your Nuclei, you can get result like this with the severity. Okay, yeah, so this slide indicates Nuclei with Langflow. In the previous session, you just see like how to set up your Langflow lab. Also, you can see that how Nuclei is configured with Langflow. So here we have taken on a small example, like we can put the command Nuclei -t for the tag templates for find out the CVEs, and we use tags. Then we have set up a then we have putting a lab which is Langflow with the -u to putting the vulnerable URL. So after clicking on enter, you can just find out the result which is marked as CVE-2025-3248 with the severity critical. So this is a small example that how Nuclei configure with Langflow. So you have an answer that what are the inside of the template, means which kind of things are inside the templates. So first we have the ID that is CVE-2025 that we found in the Langflow. Then we have the information like the name, author, severity description, that the name is RCE, which was found in the previous slide. Then we have the reference like github.com Langflow. You can then we have the classification like CVSS metrics and having the metadata that verified as true, as I told. And we use the tags like CV2025, which is the latest CVE we can use. So inside the HTTP header, we have the method like post, and we also use that code which is marked as the red block. You can see that we have used this code for scanning the targeted URL. So in the next slide, we have analyzed the result and report. Like whenever you got the result in during the scanning, you should save as a text file by putting the command -o result sqli dot txt. By putting this command, you can got a text file inside your system, which is named as result sqli.txt. It can having the data like SQL error based with the severity critical, and also having the description like check it manually. So here we have the like using Nuclei with Bobshoot. Yes, we can configure our Bobshoot with Nuclei. So let's take a overview for it. Like you should put the -u for your targeted URL, and then put your -proxy for your for configuration with Bobshoot, like -proxy, and you should put your proxy address here. Then after clicking on enter, you got see that inside the proxy HTTP history, the inside the HTTP history, the requests are captured. The requests are captured with the status code 200. By this, we can configure our Bobshoot with the Nuclei also. Also, when you can intercept the request, like in during the scanning, if you configure with proxy, if you're configured with proxy with Bobshoot, and you intercept your intercept, then it can stop scan in the Nuclei and run these scans in the Bobshoot also. Like when you forward all that requested all the request, then it can automatically resume the scan as well as scan in earlier. So then uh, we have the automating work with Nuclei workflow. Like we have see how we can configure our nuclei with the offshoot, and at here we can see how to easily work like the automated offshoot with the nuclei. So we have taken 5 steps. So from the five, we have the first, like capturing target URL from the offshoot. You should capture all the targeted URL that you want to scan. Then you have saved the target URL for a scanning. Also, you can save this target URL on a text file. Then you can run nuclei scan on collected URLs. Then analyze nuclei scan result after getting all the output that you want. Then you can save all the result in a text file. After that, you can see like how bufshoot is automated with the nuclei. So let's take a look for it. So in this slide is briefly describe that how the nucleus workflow is configured with bobshoot. So first we have the collect target URL from the Bob's sitemap. Like we have captured all the targeted URL from the sitemap which you want to capture. Then we go to then we copy all the URL in the host and paste into a text folder. You can see here we have taken a photo that indicates like save to file paste URL into a targeted.txt. We have taken a file which is marked as tag.txt and put all that requested URL we want to scan in the nuclei. After saving this file, you just you just put the list of target, like putting the command -l to scan all the list of URL that you saved as the name target.txt. After clicking on enter, you can see your output, and you can see that which kind of severity, like low, medium, high, critical, how much type of severity it show. Then go to our next slide. We have nuclear security standards. So fast up nuclear supports some kind of OS top 10, SANS 25, and like vulnerability management, CVE-based scanning, or compliance with industry. So let's a brief description describe on this topic. So fast up nuclear support was top 10 vulnerability, which are the most critical security risks for web applications such as injection, like broken authentication and accesses. This means you can quickly detect and act on the most common and severe vulnerabilities. Alongside, we have a SANS 25, which is the most software errors. These include serious issues like overflow or improper input validation and insecure interaction between components. So if your goal is broader software security, not just web, Nuclei has the cover also. So in the third, we have the best practice for vulnerability management. Nuclei also added security best practices for vulnerability management. Like these practices ensure the findings are actionable and repeatable and can be integrated into CI or CD pipelines easily. So this can help teams maintain continuously security testing across development stage. So next we have CVE-based scanning. It is one of the Nuclei's strongest features, as I told before. Like it is a CVE-based scanning. Like the templates are frequently updated to reflect newly discovered CV. So you are always scanning for the latest known issue. For instance, if there are any CV discovered in 2025 affecting a web frame, Nuclei template can include that checks almost immediately. So in the last, we have the compliance with industry security benchmark. Um, like finally, Nuclei plays well with the industry compliance requirement like ISO, PCI DSS, and SOC by helping demonstrate due to vulnerability assessment. It's a great way to ensure your organization to meet its compliance goal. So go through our next slide, which is Nuclei game-changing templates framework. It is one of the best thing about Nuclei is its massive library. Like it offer over 5,000 ready-to-use templates right out of the box. Like whenever we install that project directory from the GitHub, it gave us like 7,000 plus templates for practical use. Then we have these templates are regularly updated to include the latest CVE and exploit. So you are always scanning with the most current intel. So in the contribution friendly, which I have in the third point, that you can easily write your own custom templates and even share them with the community also. In the next we have private repository for internal security needs, like for organization with internal needs or any nuclear support for private templates repository. It's a perfect for sensitive or any security checks also. So last we have one of the largest templates ecosystem, like altogether it is one of the largest and most flexible template ecosystem available in the security world today. Okay, so go through our next slide, which is based on question answer session. So guys, if you have any query or any question, then you can put your question on chat box. We'll answer all that. Okay, so we have one question from Ayush Patra, that is it possible to get all type of output in one command? If yes, then what is that command? Okay, Ayush, yes, we can get all the output in one command, like you can put dash and tags for CVE that you have already stored in your system. Also, you can use dash NT for run all the templates you have saved in your system. Okay, so anyone else? So we have another question is from Mama. That is, what type of vulnerability can Nuclei detect? So Nuclei can detect vulnerabilities like XSS, SSRF, or RCI, SQL injection, IDOR, and some cloud misconfiguration and more. So we have another question that is, as you have explained, but then also I have a question that can we use the community edition of Bobshoot to link with Nuclei? So yes, this question is from Arish. So Arish, yes, you can use Bobshoot Community Edition with Nuclei indirectly by exporting URLs and scanning them with Nuclei, but real-time integration you should need and also plugin support required in the Bobshoot Professional. So we have like these two questions. Is there any question from your side? Okay, we'll wait for 2 minutes for the question answer session. Otherwise, we will wrap up our session. So let's move to our last slide. Hope this session was insightful and helpful for everyone. So feel free to reach out if you have any question or need any resource from our side. We are always to help you. So thank you again. So thanks again and have a great day ahead. Thank you.